So thank you for those who are here. Today I'll be talking about multi-threading in Node.js. It's kind of both an extremely useful topic to understand and also often misunderstood. And this is just kind of an outline of what we're going to be talking about. First, I'll explain what threads are, of course, and we'll ground ourselves in the synchronous paradigm of execution. And then from there, we'll look at how threading can help and use cases, some problems that might occur, what people actually mean when they typically talk about multi-threading in JavaScript. And then I'll go on to talk about multi-processing, which is using multiple processes instead of threads, how those are different, a special module in Node.js called the cluster, which is a very good module for managing multiple processes, and I actually have an interesting story about that from my last position. And then we'll just talk about key takeaways. If you take away anything from the presentation, these 4 points, which I'll elaborate on later, are what you should take away. All right. And just for my setup, I have these code examples in here. And then on the right side of the screen, I also have a terminal where I'll be executing the code. And on the left side here, I have something called htop running, which is useful for visualizing the activity of processes on your machine, as well as their child processes. So I'm running Visual Studio Code right now. I have some filters on to filter out all the other stuff going on in my computer. And the programs are going to be running in JavaScript will be another child process in here. And so they'll be at this same level. If I run another process within my Node program, it'll go even one level deeper, and that'll signify a child process. And we'll see that later on. All right. So first example, let's talk about synchronous execution, threads, and thread pools. Okay. So there's this environment variable in every node process called the thread pool size, and that signifies how many threads you can run. A thread is you can run at once. A thread is basically you can think of it as the elements that compose program execution. So a thread is a piece of execution. That's a kind of intuitive way to think about it. And in synchronous execution, for any program where, say, line 5 depends on what happens on line 4, you execute it synchronously, which means that in the single process, it's one thread at a time. And that's what synchronous execution means. And the reason we write code synchronously is because the code later on in the file depends on the actions of the code earlier on. All right. And there are 2 ways to think about threading. The first is if you're going through your code and you have to do something that's intensive, so something that, say, takes 5 or 6 seconds even, you're going to, if you're executing that synchronously, it's going to block the rest of the program. And that's what people are talking about when they say don't block the main event, the main thread in Node.js, because there's one single thread where all of your JavaScript code gets executed. And in Node.js, we obviously know that JavaScript is also asynchronous. And sometimes people reference multi-threading as the example of asynchronicity. But really, all JavaScript code executes synchronously. But there are certain Node.js is basically an interface to the operating system library as well. And there are certain system calls that are basically offset to something called a thread pool. And by offsetting code execution to a thread pool, you have another thread that executes the code while your code can continue. All right. And one of the functions, so there are a predefined set of functions that get offset to this thread pool. One of them is this function within the crypto library, because it's very computationally intensive. And we'll see this because when I execute this first example, I have the function long crypto task, which calls this intensive function. And basically, if it was executing synchronously, the first invocation would start and finish, then the second one, and then we'd get hello world, and so on. What you're going to see is that even though this looks like synchronous code, it's asynchronous. It's asynchronous, and this is going to be output for any of the others. The thread pool size is set to 4 by default, and that's what the thread pool size is, and its implication is going to make more sense in a second. But let me just go to and then, okay. So I'm going to be executing just a single node process. So you're going to see that pop up here as well. See it pop up. And yeah, got to comment out other code down here, but so basically what that shows you is that all this looks synchronous, it's not, and it's offset something called the thread pool. And the thread pool is basically this behind the scenes pre-allocated threads that we can offload certain work to. Like I said, thread pool size defaults to 4, and that means that each one of these calls is has an available thread in the thread pool that the function call can be allocated to. So it defaults to 4, so that's the same. If I set it to 4, that'd be the same thing. But what if I set it to 3? If I set it to 3, now once all of these are invoked, it's going to place this function into the thread pool, but then the thread pool is going to be completely full. And this fourth invocation is going to be queued up and unable to be processed until the others exit. So you'll see these first 3 exit at the same time. There's going to be a delay for until the fourth one. Yeah, I said 3. All right. So the first 3 exit, and then once one of the threads in the thread pool becomes available, the fourth one is able to start processing. I don't know if you saw that delay. I'll set it to 1, which basically means each one of them is going to execute sequentially, and that'll better demonstrate this principle. Okay. So it's only certain things that use the thread pool. And so there's this particular crypto function, the crypto library, and most of the file system methods from Node also end up using the thread pool unless you use the synchronous versions of them. And then there's a DNS method that uses it as well. And that's because what happens is if you have a thread that's blocking, then all other threads that could be executing are waiting on the blocking thread to finish. But many of these operations are I/O rather than computation. And so to block all computation from resuming just because there's an I/O operation doesn't make much sense. That's a good way to speed up programs. All right. Another interesting thing about threads is that, so they're all spawned within the same process, which means that they share the memory of the single process that called them. And however, each thread has its own stack. So you talk about the programming stack and whatnot, where local variables are stored and whatnot. But there's also shared memory between all threads. Can be a problem though. What if I have a variable in the main process and then I have 2 different threads and they're both trying to update that variable at the same time? Or what if the second thread depends on updates from the first thread. And so in some systems, this is corrected by ensuring that only one thread can operate on some piece of shared memory at once, and that's called thread safety. In Node.js, the threads in the thread pool are not thread safe, and so you can actually try to update variables at the same time. This is what's meant by race conditions, when, say, something that you didn't expect to operate on a piece of memory until after something else happened really didn't. There are a couple solutions to this. We can go fully synchronous so that only one thread operates at the same time, but we know that that's bad because that prevents other threads that could be executing from doing their job while they're waiting. We could also use a different paradigm of programming called event-driven programming with multi-threading. And we're getting to what Node.js uses here. So all code is executed in the main thread, but if a blocking operation is detected, such as the one that I executed up here, then it's going to be, that operation is going to be placed into queued up, and once a thread in the thread pool is available, the thread in the thread pool is going to execute it, saving the main thread from executing. And this is kind of pseudocode of a very high-level overview of what's happening in Node.js with the event loop and the thread pool. Basically, while there are events in the event queue, get the next event to process. If there's a callback associated with the event, then execute that callback. And if any function that's invoked is blocking, offload that to the thread pool. And then what we're going to do is, when we offload that to the thread pool, assign a callback to it. And that callback can terminate when the function in the thread pool terminates. So that's like a termination event. And this is very basic event-driven programming. All right. So I'm going to show you what can happen when you just assume that threads have their own memory. Right here, I initialize a variable a, it's just an integer, in the basically the process that's going to be using these different threads. And then I have two long crypto tasks. So and the only reason I'm using this crypto task again is because we know for certain that it's going to be offloaded to the thread pool. And each one is going to modify a in some way. Long crypto task 1 is going to increase the value of a by 1. Long crypto task 2 is going to decrease the variable a by 1. So if this were synchronous code, say for some reason I wanted to go have variable a be 1, then 2, then 3, then 2, then back to 1. That would work in synchronous code because on line 88, the function would not execute until the function on line 87 completely finished. But as we know, it's not going to happen because these are offloaded to the thread pool. And so what's going to happen is that since these threads share the same memory because they're from the same process, it's hard to tell what the order is going to be. It's not going to be 1, 2, 3, 2, 1, and we'll see that. Just make sure I commented out. Okay. This is because, like I said, thread pool behind Node.js is not thread safe by default. Okay. So 1, 0, 1, 2, 1. So not what we expected. They did not, if they had executed in the proper order, like each invocation logs A, it would have been 1, 2, 3, 2, 1. But they execute in random order based on when they finish, which is not deterministic. And so you see that this is, in a real application, if you have very important, crucial data, and you have multiple threads operating in the same data, you have to make sure that they're not updating or reading that data in the wrong order because it's not done for you. And I can actually that's fine. So what can we do about this is the next question. Since it's not thread safe, is we can use event-driven programming. So in here, in this example, I'm just making the functions operate on A without doing anything. It's not checking for any event to have happened first. So I'm going to modify it like this. And I know this looks like a lot more, but all I'm doing is in the main, in the process that offset these threads to thread pool, I'm storing the amount of times task 1 has completed. I'm storing the total time something has executed as well. Okay, and because I am doing that, any threads that I associate with this process will be able to view these variables. I'm actually going to comment these out because they're not useful for this. And then what I'm doing is basically putting some conditionals in place. So if task one when it's called, it's going to check if task 1 counts less than 3, or if total less than or equal to 5. And the reason it's doing that is just because I wanted it to go 1, 2, 3, 2, 1. And so since task 1 is what increments the value of A, I want task 1 to execute at least 3 times and not task 2 before task 2 starts to execute. And so this task 1 will either call itself again in a recursive fashion, or it'll call task 2 if it's time for if it's time for A to start being reduced instead of incremented. And this will actually reduce A to a little below 0, but that's fine because that's not the point of the example. That was actually unexpected because obviously I ran these examples first. So okay, I'm not sure why that's not working, but luckily this isn't a programming interview, so I don't have to debug it. But I will just take a close look. If anyone sees anything, send it in the chat. Oh, silly mistake, I forgot to save it. Okay, so as you can see, now it's executing the right order. Even though these are offloaded to the thread pool, we've kind of faked asynchronicity. But the reason is that if you look at this code, we're only actually executing this function that gets offloaded to the thread pool one at a time. And so we're not using multiple threads actually, just that one extra thread. The advantage, of course, that we can simulate this synchronous execution without polluting the main thread. So even though this is one thread at a time and therefore slow, it's not the main thread where all our other code lives. And that's helpful if we were doing a lot of other things in a real application. The other way that we could have done this is, like I showed in the first example, is limit the thread pool size to 1, and then executed this example, would have resulted in the same thing. So that's the basic what that's what threads look like in Node.js. So when people talk about multi-threading, they talk about forking processes and things. That's not really technically what multi-threading is. In Node.js, the multi-threading refers to the use of the thread pool. And the use of the thread pool, like I said, only occurs when certain predefined functions are used. Otherwise, when we talk about asynchronicity, well, there are other ways that asynchronicity is achieved in Node.js, not using the thread pool. And that's just basically, as the main thread executes, there are, the event loop is iterating and checking for any new events pushed into something like a queue. And of course, when you attach a callback to something, or rather an event listener to something, which sometimes is through a callback, then that callback gets associated with the event. So when the event loop detects that that event is in the quote unquote event queue, then it's going to execute the callback. However, callbacks do not necessarily equal asynchronicity. If you think about like an array.forEach, you pass it the callback each time, but array.forEach is completely synchronous, and there's no waiting at a later time when some event occurs to execute that callback. Okay, so now I'm just going to show you the basics of processes. So if threads all share the same memory in a process, and threads are the basic units of execution you can think of, they're at least from the developer's perspective in a high-level language, you can think of it like that, then processes are like completely isolated, not completely isolated, but isolated applications. So each application running on my program is something like a process. So I've got Visual Studio Code open, I've got Google Chrome open. Those are different processes, and they don't share memory with each other. And one way to use processes in Node.js, just way to use them simply, is through the child process library. It's given to you. And what this code is doing is I don't need to set timeout at first, but there is a reason for it that I'll show you. So what I'm doing is I'm calling child process.fork, and that will return a child process object for me. And basically what I'm forking is this file that's executing a really long task. Basically, it's a loop that goes to like 10 million or something. It's just supposed to take a lot of time. And then once that process completes, it's going to close. And when it closes, it's going to emit a close event. And so this main process, the parent process, is going to catch that close event and then log to the console that child process is closed. If you remember, let me just show you real quick what it looks like when I execute a normal Node application or Node program. It's just going to show that one child process of Visual Studio, but you can think of this as just a single process, and that's the Node script. So what should happen is I should get another one that's even farther down the tree, which will indicate a child process of the Node process. So let's okay, so that is a child process of the Node script, and obviously that loop was like 10 million, so it took almost 5 seconds. And once it finished, the main process caught that event and logged it. Okay. And as we saw, threads can share memory. but child processes cannot share memory. And so if I initialize the variable a in the parent process, and then in this code that I'm executing, I try to log it, and I find that it's going to throw an error because A isn't defined anywhere. So they have completely separate memory spaces. Right. Child process is useful sometimes. Anytime you need really to spawn a child process to do something computationally intensive, it's useful for that. But if you need to manage a lot of processes, there's something more sophisticated. And let me just show you set timeout so that you can see that if I keep a set timeout here, what's going to happen is that the node 1, basically the parent process of the node script, is going to stay open, and it's just going to allow you to see the child process disappear, but the node process continue to exist. A little bit better. I think I need. Okay. So main process, child process. Yeah, it still wasn't. Okay, just take my word for it. The child process exits. And if you have a lot of code, then you'll see that the main process will continue to exist. And kind of, it's set timeout doesn't necessarily guarantee. Okay, I'm not going to go down that rabbit hole right now. Okay, so child process useful for spawning processes to do some task, but there's something more sophisticated, a library called cluster in Node.js, which allows you to basically have a master process that you define, and then you can basically manage a bunch of child processes, close them, send them messages, communicate with them in with a much easier API. And I actually used this at my old position once for, it's kind of a war story, is we were processing a huge amount of data, but the service, we outsourced the development of this particular service, and the person or the developer who sent it back didn't include any sort of multiprocessing capabilities in the service. And so what happened was, during a time of high activity, so the service was receiving a lot of data, what happened is that that server froze up and then crashed. And it took a few hours to repair that. But the task I was assigned was to basically fix that code so that it doesn't break the server down. And obviously I can't control how much data comes through. So first, what I did was set up multiprocessing. So the service's main process would receive all this data and would stream it, so that, because you can only hold so much data in memory, would stream it and then place some of that data into each worker. And but ultimately, all these child processes would still have a huge amount of data, because the total data was still too much for, say, 8 processes to handle all at once, even if they divided it up evenly. So what happened was we would batch I set up a stream so that the data would come in and get stored somewhere, and then this service would periodically read from the stream a tenable amount of data, split it up, send it to each child process, and then basically batch process that way. And so cluster is very useful, and it solved the problem. That was a big problem. So it's a very powerful library we can use. And I have here a very simple example that's yeah, what I did was basically a little more complex, but the same thing is first I'm going to read some data from that's stored somewhere else. And then I'm going to initialize different child processes, send them a portion of the data, and then once they're done, they're going to send a message back to the parent process saying, you know, I have completed. But in this case, since it's just a very simple example, all the child process is going to say is acknowledge they received the data. And then we'll see what happens. So in cluster, it's basically the same file gets executed, whether it's a child process or master process. And that's why cluster provides this method isMaster. So isMaster is the default. If you haven't spawned a child process with cluster, it's going to be isMaster. And so this part of the if conditional is going to execute on the master process only. And what it's going to do is first read the data from this data file, which is just an array of 20 numbers. It's going to split that data in half, and then it will create two child processes. So when you call cluster.fork, what happens is it returns this worker process object. And this first argument here is actually setting the environment variables. So if you notice in Node, you can view any variable in that process's environment. Well, by doing this, I'm setting a two-process environment variable on each of those child processes. And then I'm assigning an event. So basically, if this master process receives a message from worker one, so from that first child process, it'll log that, and same from worker two. This else conditional tells is basically what the child processes are going to do. And like I said, they're just going to send this message and say, I've received the data, and they access the data through the environment variable to process that I set here. Okay. And so I have two child processes now because I did two cluster.forks. The interesting thing is these processes stay open unless you do something about them. So you see that both processes have received the data and then sent it back to the master process. The master process logged what it received from the child processes. But these child processes stay open. And so one common mistake is you have all these processes being forked, and then you don't disconnect them. Actually, when I was solving that problem with the servers, at first what I was doing was trying to preserve these processes, because spawning a new one obviously takes a little bit of extra computational power. But the way I was passing the data was through the environment, through environment variables, and so I couldn't continuously pass new data through new environment variables to these child processes. So what happens is, luckily, cluster allows you to send messages back and forth, and so they were basically just, I was preserving these processes and added a handler in the child process when it receives a message to start processing data. And so that's just another example of why cluster module is so good. So, and finally, once they were fully finished, they'd send a fully finished message, and then that's when the child process can be closed. And we do that with the process.disconnect method. And so if I keep it on worker one, if I place this on worker one but not on worker two, you'll see that both messages are received, but one child process will remain open in here. So shut those down. So the child process 1 was shut down, but child process 2 was preserved. And you want to make sure that you're always disconnecting these after you're done with them, because yeah. And since the master process didn't need to keep either one open, it exited right after it logged those messages, right? And okay, so that's kind of a lot of information. Like I said, when people are talking about Node.js multithreading, mostly what they're talking about is the use of multiple processes, or they're talking about the thread pool. The thread pool isn't something that you can really just go and place things on. There are predefined methods that get placed on it. Since the thread pool has an upper cap, you can set the upper cap. So like I did in the other examples, you can control the size of the thread pool. And that's the amount of threads that will be available in that thread pool at any one time, so max 10. If you have an 11th thread that gets offset to the thread pool, it'll have to wait. And it defaults to 4. So, but the fact is that there's always going to be an upper cap, and the actually hard-coded limit is 128. If each thread in the thread pool takes a long time, that's not useful, because now those threads are being occupied for a ridiculous amount of time as well. So just because you have an intensive IO or CP function, that doesn't mean that offsetting it, if it's already being offset to the thread pool, that doesn't automatically mean that it's safe and taken care of. You still have to make sure it still behoves you to optimize and make it as efficient as possible. In Node 11, there is now something called the worker thread library. It's still experimental, but that allows you to use not just spawn processes programmatically, but separate threads programmatically. And that's good when you have something that's not going to be offset to the thread pool. However, the thread pool is still better. So if something would already be offset to the thread pool, don't spawn it with a worker thread. And you can use multiprocessing if you have multiple cores on the machine in order to basically distribute the work so that no single process has too much work. And the consequences of not doing that is something like a server crashing, like in that story that I mentioned. So that's basically all I have. If there are any questions, you can send them in the chat or the Q&A. I'll basically just leave it open for like 10 to 15 seconds. You can also send me messages on Slack if you have any questions about this or want to dive into it further. Be sure everyone. Here's my handle.